Welcome, everyone. Thank you for taking the time in the afternoon on the last day to come and watch me tell you about how I learned C Sharp. Okay, so how do you actually learn a new programming language? Because that was the problem here. I could submit a talk on learning it and actually get it accepted, and that's how we got to this point. It's been kind of on my backlog for a long time to learn C Sharp. It's kind of been a thing that I felt that I should know. And it was sort of a joke, sort of a timeline, sort of a something. And it's been quite interesting. So where do I start? By procrastination. That's usually how you start any big plan on how to do anything. And then I ask on Twitter, it's like, okay, so you people know C Sharp, what should I know? Then watch lots of videos, read books, try to get a development environment, write some code, take a lot of notes, freak out, and then make a flow diagram. Okay, so trying to learn C Sharp. Who am I? My name is Patricia Aas. I'm a trainer and consultant these days. I like to call myself a C++ programmer. I'm currently focusing a lot on application security. I started my own company, or co-founded a company last year called TurtleSec. So if application security is interesting to you, let me know. My first real job after university was at Opera Software, working on the original Opera browser. Then I was a Java consultant for a couple of years. Then I worked at Cisco, making embedded telepresence systems. And then last at Vivaldi before starting TurtleSec. So I have a master's degree in computer science. And while I was at university, my main language was Java, but with a lot of other languages as well. So if you have a baby language, how does this actually work? How do computer languages become computer languages? Do you have some kind of genealogy? Do you have some kind of like, my father language was this and my mother language was this, and look at mini-me? Actually, probably maybe in the beginning. But in the end, it's more of a cross-pollination. It's like, it's a Git tree, but you can kind of cherry-pick features, and then you alter some of the syntax. And the thing is, the whole thing becomes sort of like a mesh. So is this good, bad, both? Yes. and that's a lot of what we'll see in this talk. So first of all, I'd like you to look at this little program. So the question is, which programming language is this? I'm not saying it's a good example from this programming language, but which programming language is this? What about this one? I'll help you. The differences are those. Actually, yeah, it's C# and C++. And you probably didn't know you could write so similar examples, did you? Okay. The thing is, these are pretty much evil twins. They don't really mean the same thing. The syntax is very similar, but the semantics of the two programs is widely different. C# and C++ are very different languages. So you could write two programs that look almost the same, but mean very different things. And this makes learning a new language hard. And so while I was learning C#, I was also thinking a lot about this. And then my daughter, who's a language nerd, she started talking about learning languages in general, like natural languages. And actually, learning languages, natural languages, is something that there's science around. So I started to look, what does the science of natural languages? What does that have to show me? And so if you're an English speaker and you want to learn Spanish, then you take a word like telephone and you try to Spanify it, and then you try to go for teléfono. And in this case, this is right. And the reason why this is right is something that they call in linguistics cognates. They are related. They have the same origin and the same form and the same meaning. So this is great. This means you can basically skip over a lot of things. You can get by with like guesswork. And this is true a lot in programming as well. But you have other things that, like much, and then trying to go for mucho in Spanish, which is right in this case too. But this is actually a false cognate. And the reason for that is that these are the same form and meaning, but it's by accident, because they're not actually related linguistically. But seriously, who cares? Because your mental shortcuts are working. And if you can do that while learning a new programming language, you're basically just using the experience that you have and guessing what things mean. And many times, that will be right. And so you can fast track learning a new language. And so you look at a program, and then here you have some C#. And it's quite straightforward. We have some sort of printing to the console thing. And this is a little bit different from language to language, exactly how you say write something to the console. But you know, the console word is pretty similar from JavaScript, and so you kind of guess what this does. You have some kind of var. It's not totally clear if you don't know anything about C# that this is statically typed under the covers, but it is. And then you have some kind of list where you put integers into it. So you basically feel like, okay, I can get this. You have some kind of for loop. It does list.count instead of size or length, but you know, it's pretty obvious. And you have a for each, which is also, you know, it makes sense. So looking at this, you think, okay, so there's no real surprises here. You can think that C# is an imperative C-like language, and I know imperative C-like languages, so this I can do, right? But then you can look at the same list again, but start to think, okay, so maybe I can do this instead to write to the console. So same list, but now it's not really looking very imperative and C-like anymore. It's looking maybe more like a functional Lisp-like language. So these cognates are great, but sometimes this algorithm of mapping what you know to something you don't know doesn't really work out. So in Norwegian, we have a word called pig. In English, there's a word also called pig. And so if a Norwegian not knowing English very well tries to form an English sentence, they might say, I had bad pigs in my tires. Unfortunately, pig in Norwegian is stud or nail, so it did not mean what you thought it meant, right? And this is a problem they call false friends. So these are words that sound the same and look the same, but mean different things. So they have the same form, but a totally different meaning. And you see that in programming as well. So these false friends, they give you bad assumptions. And this is the time when your mental shortcuts, your guesswork, your spanglifying is hurting you, right? Same thing you have in Spanish. I don't know if you have Spanish speakers, but the English word embarrassed, Spanified, is very easy to jump to embarazada, which means pregnant. I did that, unfortunately. Okay, so a special version that I call drift in meaning of false friends is something that I'd like to look at. So in Norwegian, we have a word called frokost. In Danish, they have a word called frokost, said in a Danish way, which I can't say. But in Norwegian, it means breakfast. In Danish, it means lunch. Which is really unfortunate, because it's sort of like the same context that you'll see it in. And so you will think that, you know, that it's definitely, we're talking about a meal. And this is a drift in meaning, because these words have the same origin, the same form, but they mean now different things. So let's look at some programming things in this, right? So you have list. In Java, you have something called a list. In C#, you have something called a list. In Java, a list is a linked list. It's actually a data structure you usually don't use because it's quite inefficient, and it's mostly academically interesting. In C#, a list is actually what in Java they would call an array list, or what we in C++ would call a vector, a much more interesting data structure. But if I see the word list and my language is Java, then I will think it's a linked list, because that's my mental shortcut. So there you have a drift in meaning. Of course, they have the same origin, the same form. It's like all of this, it's like everything is Lisp if you go far enough back, and in Lisp everything is a list. But they don't have the same meaning. So you have this concept of an origin, where things came from, what the words mean, or the constructs mean, and what form they have. And that form can change or can be different from language to language to express the same thing. So you have the cognates and the false cognates, and in my opinion, who cares? It doesn't really matter if something was actually related in some kind of programming language hierarchy. The most important thing is that your shortcuts are working, right? They have the same form and they have the same meaning, so guesswork will actually work for you. The problem is when things look different, because if they look different, it might be hard to know what they mean. But usually, surprisingly, what I realized doing this is that things that are different in form are usually okay, because I can tell from the context what the word does. Like, what is this thing? I can tell from the program context what it does. The hard part is the drift in meaning, because this is when I make the bad assumptions. This is when I think I know what it means, but it actually means something else. And that's the world of the false friends. So, how do you learn when everything that you learn is based on what you know? Because then it becomes very interesting what I know. If I'm going to learn C#, then what do I already know? So my absolute first programming language was Scheme, which is it's in the Lisp family of languages. So it's a very functional language. And that was my first experience programming. It made me fall in love with programming, but I quickly ended up doing more imperative programming, so I was doing Java at university. Lots of other languages as well, but professionally, I've been mostly doing C++ and C. But I've been programming in maybe, 15, 20 maybe languages in my career, so I have lots of different examples of programming languages in my experience. And some of them I'm really bad at. I'm really bad at Perl. I've coded professionally in Perl, and Perl programmers will shake their heads at my code. And that's also something that I found interesting in this process, is that you can have an accent in programming. And the thing is, now, like if you think back, if you come from one programming language and you start coding in another programming language in the same way, that's an accent. And my accent in Perl was C. So all of the Perl programs were like, okay, Patricia, you're treating this language like it's C. And I was like, but it works. and the same thing, and some cultures are very strong, like in Python community. If you come in programming like it's C or Java then they will get really annoyed because they'll say it's not Pythonic, it's not idiomatic. The word idiomatic means you have an accent. If somebody says it's not idiomatic, they say you have an accent from another programming language. So I've been programming from 20 years-ish. So this is my mental baggage. Or skill. It's hard to know sometimes. So the thing is, if I'm going to learn a new programming language, I'm not going to read 700 pages book from cover to cover. It's not going to scale, and I'm going to throw it away before I start. So I need some way to figure out what to skip. I want to jump ahead, jump past all of the normal stuff, right? Because the languages are inheriting from each other and cherry-picking features from each other, so I should be able to skip lots of things. But the problem is the false friends. I think I know what it means, but it actually means something else, and I probably should have read that chapter, but I didn't know because I thought I knew what it meant. or the unknown unknowns. Like, what are the things that I'm skipping that I actually should know, but I don't have a reference for? And so I make a plan. I'm going to skip over all the cognates. I'm going to try. So I'm going to at least skip the beginning. So all of this is a for loop, this is a variable, this is continue, if else, what does break do in a loop, all of those things, is like we're skipping those. But how do I know I'm not missing things? So now I'm getting stressed out about the thing because I'm skipping too much, right? So now I'm worried. I'm missing important things. So maybe I should like skim. Maybe I can watch like the videos on like twice speed, just so to make sure, like maybe there are some like nuggets in there somewhere. And this is where I think programming education is failing us, because we should have like a 2-page summary in the beginning of a book that says you can skip to chapter 5 after reading these 2 pages. And it's like, yeah, all of the for loops are normal, all of blah 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 is normal, var isn't actually statically typed thing, dynamic is not, and just like a quick introduction, and then skip to chapter 5. So how do I learn the basics? And how do I find the surprises? Because the problem is, to find the surprises, I have to go through everything. And there's way too much repetition, because you have all of these cognates, all of the things that I wanted to skip. And there you find things that have drifted in meaning. My false friends suddenly become weird things, like namespaces and defines. So I'm going to use this kind of structure a little bit, so I'll show you. So the language in the little box there is my recognition language. So this is the language I was thinking of when I learned this thing. Like, this is how I mapped it in my mind. So in namespaces, I mapped to C++. Because the syntax is very much the same. It looks very similar. This is how C++ also looks-ish. But the thing is, this is C#, and the semantics are a little bit different. I would probably say that C# namespaces are probably more leaning towards what is going to become modules in C++, which has like a totally different syntax. And so I'm not sure. And this is going to trick me, because I think I know what namespace means, and I don't know what namespace means. And C# has defines. I mean, seriously, this was so much fun. I'm like probably the only one that's actually found this fun. But you can do this. You can have defines in C#, and you can use them to do things. You probably shouldn't, but you can. And again, this is not really defines the way I know them from C and C++. There's no real preprocessor. There's like almost like 90% of everything you can do with the C++ preprocessor you cannot do with C# defines. So this is a false friend for me, and probably for a good it's probably a good thing. Nobody probably wants me to use defines in my C# code. But it's possible. So if I have an accent, I might actually do this. I'm coming from C++, programming C#. Maybe this will influence how I code. But then you have things that are easier, right? Like cognates, operator overloading, optional parameters, name parameters, and struct value type. Operator overloading is something that I like. It's very controversial in most languages, but I kind of like it. I like to be able to express semantics in this way, saying that I want this box and this other box in one bounding box, and I can do that with plus. Or with unions, you can have like plus and minus and things like that. I like that. Having things like this, like, okay, I want to have this first and this second, and I want to add them together to create the bounding box around them, and then that box will have the right dimensions. And I'm not going to go through all of this, but I like it. It's nice. It's a static function, but it's possible. So then you have optional parameter arguments, and this is also most languages. It's like, is it good? Is it bad? I don't know, but sometimes it's useful, and so you can do that in C#. So that's interesting. That's one of those things where I will find them interesting. You have name parameters, which I also find interesting. We're getting some named parameter syntax to C++. Probably not as powerful as yours, but there will be something. And I kind of like it. I don't know. I haven't programmed a lot with this kind of constructs before. But the struct. Now this is where it's like you're coming home. It's like, welcome. So a struct in C# is very close to C++ in Soul. And the meaning and the semantics of it is very similar. And that's really important because for me, structs have a semantic, even in C++. Because in C++, structs are basically just classes, but they have public access. This is not true in C#. They actually have private access. You have to write public, but they're very similar in the way that you treat them. You have a little bit of a drift in form, but I would still say these are cognates. This makes sense to me. And the only difference is in C++, everything is a value type. So as long as I stick to being able to move, think of values only as structs, I'm okay. But I like this. I don't think Java has value types yet. Anybody know? And so this is something I miss when I program in other languages. I really like value types. But then you have drift in form. And these are surprisingly okay. You have properties in C#, and properties are surprisingly popular. Because coming from most other languages, all of the setter and getter stuff has become very unpopular in most languages. So you basically say if everything is public, then just have a public field. Just get over yourself. It's not more complicated than that. But I think the reason why it's so popular, actually, primary reason is this. It is quite a nice syntax. It's very compact, it's very expressive, and it's very easy. And I think that this is one of the reasons it's very popular. The other reason is probably how you compile and link things together. It makes it a little bit better having functions versus fields. But still, I think the syntax is a big reason why this stayed popular in C# and fell out of fashion in Java. Well, okay, it depends on who you ask. But there are cool things you can do. You just drop the set, and now suddenly it's a read-only property. You can, of course, I had to try if you could just drop the get and just have a setter. Write-only property. But apparently, that's not allowed. But you can do similar things. You can make the get private, or make the set private, which is probably more reasonable. It's a strange thing to have a field that anybody can write to. But then I encountered this kind of syntax. And I was really wondering why would anybody do this, but then I realized this was how C# people implemented properties in the beginning. Because I asked on Twitter, why would you do this? And of course, you could do this if you have more elaborate logic, but I saw a lot of code that looked basically like this, and I was like, why would you do this and not do the simple syntax? But apparently that's a legacy thing. But overall, I think properties are kind of nice. And for me, properties are more related to Qt. And in Qt, they are a very powerful mechanism to have bindings to the UI. And if you haven't tried Qt and QML, I really recommend it. That's really, really nice. And then you have this magic value thing that you can use. See, for me, everything is new. I didn't know. I had never written a line of C# before I started learning it this time. So you have out parameters. Now, this was really interesting to me, that you have a specific keyword to say that this parameter is an out parameter. I don't think I've seen that in other programming languages. But semantic-wise, it's fine. The one thing that I thought was nice was this one part here where you can actually declare it in the call. That's interesting. I've never seen that either. But for me, it's semantic-wise, it's fine. It's basically you're passing an int by reference. So that's fine. I don't have a problem with that. Of course, it was hard for me, and this is something I saw many times, that people don't explain concepts in like common words. And so you kind of have to figure out, what does this actually mean? And that wasn't the worst one, though. I'll get back to that later. But then you have null conditional operators, and these were surprisingly simple to understand. So we have this function here, get coffee, which takes a list of coffee shops and an index. It's not a very, it doesn't make sense programming-wise, but stay with me. I have a thing for coffee. So the algorithm here is, if there are any coffee shops and there is a shop at this index, then I want you to get me coffee from that shop, and if not, just give me 0, which is kind of long, but it just turns out to be like this question marky thing. And it kind of makes sense. There's a lot of question marks in that one line, though. It's like, I'm not really sure about this, but yeah, I think this could grow on me. And it just kind of fits together quite nicely. So I like it. But I had some false friends, and you've already seen sort of my biggest false friend. Coming from C++ to C# is this destructor/finalize method. And this would probably be surprising for most C# people, because you don't use it, do you? No. But the thing is, C++, I would say, if you would find and dig out the heart of C++, it is the destructor. It is the like if you really reached in and just grabbed it, that is C++. It is the destructor. And it was killing me, because C++ finalizers, C# finalizers are also called destructors sometimes. And they look exactly like C++ destructors. But they are a little more like Java's finalize, which is an absolutely useless method. Because the problem is, it might be called by the GC, maybe. It's like there's not even a contract that it will ever actually be called. And even if it is called, at what time is totally, you don't know. So there's no reason to put anything interesting in this function. So for me, it becomes noise, right? This is something that has the same form, but the meaning is totally different, and it's not really useful. And so for me, it became like a sidetrack. I had to figure out what this function does, because I thought it was important, and it wasn't. So that, taking us out like of the syntax, then I have to try to understand the semantics. And this is like, how do you think when you code in C#? What is like the middle of C#? Beyond like just the basic syntax. Yeah, there's some imperative language influence. There's some functional language influence. But what is C#? One thing that kept on coming up in books and in videos was this Idisposable. And of course now it's like back to my destructor feeling. It's like Idisposable. I need to look at this. And Idisposable is quite nice. It's a little bit similar to Java's closable. And it has sort of the same functionality, but I would say probably in C# it's more elegant. You have more constructs to use it. It's especially in later versions of C#. So I actually like it better with these using syntax. There's the drift in form, but I understand what it means. I have a mental model of what this means. And so it's quite easy for me to learn. So it has the same semantics, different syntax, but I can learn that. One thing that was harder for me was yield return. And that's because my Python isn't really good. And I really felt, and so probably my next language I really need to learn well is probably Python, because my Python isn't really good. But I think my Python is better now for learning C#. But you have this enumerable thing where you you can return the next yield return. And this becomes, and I was trying to figure out what this was, and it took a while because I need to find the words in my head to map things. And so I called it a lazy iterator. Of course, if you're coming from Python, you probably call it a generator. But I didn't really have that mental model, so for me, it became a lazy iterator. And John Skeet, who was so kind and sent me his book, seriously, had in this book, actually, this really cool example. So this is a generator generating Fibonacci numbers, and that's all the code. And it's using this mechanism. And being lazy means that you're basically just getting the next Fibonacci number every time you call it. I thought this was really cool. You probably think this is totally normal, but I'm not used to this, so I thought this was really cool. It kind of brought me back to my Lisp roots. I'm like, oh, okay, so this is very functional. And then I found extension methods. And people on Twitter, they were really talking about extension methods. They were like, oh, extension methods are one of the really coolest things in C#. And I had really nothing to map it to. But I agree, it's pretty cool, actually. And especially in C++, I think we would like to have something like this, because we do have very sparse interfaces sometimes. And here you can actually add functionality to existing third-party code. And I really like that. So you have this target class, and you want to add some functionality to it. And it has no functionality currently. And so I can make this function called print-hello, which takes this target T and does a thing. And that means later on, it just magically kind of appears. And suddenly I can add functions to existing classes and add functionality to them. And I thought it was quite cool. And I think it could be very interesting in other languages. But how do we teach? Because the thing is, again, I'm coming as a programmer. I know how to program. Don't teach me how to program using C#, because I'm not interested. The how to program thing, I know. I want to learn C#. So how do we teach someone who already knows how to program? And this became something I kept thinking about. We need to use terms that people recognize. And so I'm going to show you the place that I got stuck the longest, learning C#. And you're probably going to think it's a silly place to get stuck. Because the problem is, when you use terms that people recognize, then you can also say, okay, this is like this other thing, but this is how it's different. Or you can, at least you give people a feeling of which mental headspace you should be in. Like, what is the mental model somehow? And then you can manipulate it, and it goes much faster. If you don't have any kind of mental model, you have to learn it from scratch. And I have an example from Norwegian. Because this is again like the unknown unknowns. In Norwegian, okay, you know when you have snow on the ground and it melts a little bit, and the top part of the snow, it freezes again. It's sort of like an icy layer on top of the snow, and you can actually grab it and like take it off in like these sheets. In Norwegian, we have a word for that. We call it skare. We have a word for that. That is crazy. If anybody comes from Spanish or anything, there's no way they can guess that we have a word for that. And that's the problem, and that's the thing that started bothering me more and more, are the things that I didn't understand that sounded like they were new. And sometimes I realized that they were just using language I wasn't familiar with. But sometimes I was worried just about what are the things that I'm missing that I don't know to ask for. So delegate. Delegate took me a long time. I watched several videos on delegate, several actual like a plural. There was like a plural site course on delegates, or they had a couple of other things, but I was really focused on the delegates part because it sounded really, really important. Like people were talking. There was a keyword for this. It's like Delegate. They had like a whole keyword. I'm imagining this to be really important. I have to understand. And then people say, oh yeah, but it's used a lot in things. So after studying delegates, I can tell you it's a fancy function pointer. So let's look at fancy function pointers. So you have a delegate. It has a delegate signature. So you have the signature of the function. So here we have a public delegate void print me. It's the function signature for a function pointer. You can define the function, and then you can use it. So function pointer type, function definition, function call. See, if I had been given this, I'd been spend like 2 minutes on this concept. Instead, I was watching video after video of people talking. Not understanding what this was and why it was so important. Why are they talking so much about this thing? There must be more. And there is more. Because it's not just a function pointer, it's a fancy function pointer. So we have to get to the fancy part. Okay, so the fancy part here is now we have two, right? So we're using the same signature we had before, which was the print me signature. And so we have first and second. Both are functions. Okay, are you ready for the fancy? You can plus. You can have a function pointer plus another function pointer, and you get a third function pointer. And so what does the function first that prints hello and the function second that prints world print when you call hello world? Which, seriously, this was kind of cool. I don't know, it was kind of cool. You have defined operator plus for function pointers. And not only that, there's like operator minus as well. So you can actually like minus a function pointer from another function pointer. And apparently even my IDE thinks that's a bad idea, but it is possible. And I found this to be pretty cool. I'm not yeah, I've never seen it before, but I kind of like it. So that's the fancy part of the function pointer in delegates. And then, of course, somebody comes and talks about events and event handlers and blah, blah, blah. And I thought we were on a totally different subject, but actually event handlers is just a predefined function pointer type. So event handler is a function pointer type that is predefined by C#, and you don't have to think about it, but it's all the same thing. It's basically, you have to define a function. And now you can use this function. And of course, we can use the null question marky thing syntax. And you can use this for callbacks or click handlers and things like that. And it's nice, but it's not like earth-shattering. And it bothered me so much that I spent so much time trying to understand this concept. Because it's not complicated if I'd been given the right words. And I think that's probably one of the problems we have when trying to teach programming to programmers. We actually have to use words that map to what they already know, and not treat everyone like they don't know how to program. Because most people who learn how to program know how to program. And we keep on teaching like people don't know anything. Like you have to start, okay, so this is a computer. You know, in movies, when you shoot the screen, okay, the screen is not the computer. The computer is like the box that you don't see. We need to teach beginners, but we need a better way to teach experienced people. We need some way to know what to skip. We need some way to figure out what to pay attention to. Because that was my problem. What are the surprises? And it kept bothering me all the time. What are the surprises? What are the things that I'm missing? And the first thing that brought that home was decimal. This was like a real big moment for me. Do you know about decimal? Is this like something people use? No? Okay, there's a type in C# called decimal. There's a non-zero based array, okay? That's weird. And then you have the nullable types. But the decimal thing, that really, really bothered me. Because here you have a whole fundamental type that I'd never seen before, that was just listed among the other types. it's like, and this was an example of the things that I would miss if I was skimming or jumping over things. Because decimal is a 128-bit floating point type with 28 to 29 significant digit precision. Okay, so this is, okay, so who cares? Okay, who cares? Yes, because that doesn't exist in any other language that I know of. So I had no reference, I had no reason to believe that this thing existed. And this bothered me, because the moment I saw it, it was an example of what I was afraid of. There are things that I'm missing by jumping, right? But then you had non-zero based array. And this was not good. And the code looks terrible, and I think that is a good thing. Okay, so I'm not going to go through it. You can create a non-zero based array in C#, and you should not do this. And it is clearly demonstrated by how ugly it looks. But it's interesting, because why? Why do you have non-zero based arrays? Somebody thought this was a good idea at some point. Okay, but nullable types, because those were also a surprise. I learned about nullable types when learning about the question mark dot operator. Because suddenly people were talking about, oh, this is a nullable bool. And I was like, a nullable bool? You have a bool question mark. Now I've seen in some frameworks in C++, you have like a three-state bool, which is a yes, no, maybe. Which is always bad. In Java, they've always made these kinds of things by having like a Boolean object. And then the pointer to the Boolean object can be null, and so then you can have null, true, and false. And as we saw with like the out keyword for an out parameter, an out parameter in Java would be the same. You could have an out parameter that would be an object, and then you can mutate the object. They don't have this concept. And so one of the things that I like and struggle with in C# is how it has made syntax for things that in other languages are just constructs you make up. There's actually native syntax for a lot of things that don't exist in other languages. And that's good, because it makes the code nicer, and especially if they're useful things that people like to use. But sometimes it makes me wonder, what am I missing? Like the bool question mark, which is, it's nice, but you have, again, like we saw the question mark before, and the question mark is, if maybe is null, then which kind of Boolean value should I take instead? So this is like a sort of a default value kind of thing, which in C++ you could probably do just maybe or true, because we do that. We can interpret a null value as in a truthiness kind of way, which it doesn't exist in C#. But then I found some JavaScript love, because I was coming at C# very much from a Java, C++ kind of direction, and then adding in maybe some functional stuff. But I didn't expect to find native support for JavaScripty things. So you have anonymous types. They, syntax-wise, looks a little bit like JavaScript. And then you have the expando object. This expando object is somebody who really, really drank their JavaScript juice. We'll get back to it. First, anonymous types. And I think it's kind of nice if you kind of squint a little bit and just kind of not see the new stuff. It looks kind of like a JavaScript object. And it can be very nice for, especially I would imagine this would be really nice in tests, because it makes it pretty clear. But the expando object, people. This was awesome. Okay, so yeah, here, finally, we have dynamic, which is quite a cool word. It's very long, like you had the var, and then you just, like, you could have gone for like din or something to like match it, but no, it's like dynamic expando object. And this is basically a JavaScript object in C#. And it means you can do like weird but cool things you can do in JavaScript. Like this. I can add a field. And then I can access it like any other field, like it had it already. This is one of the weird things that you can do in JavaScript, which is also one of the cool things that you can do in JavaScript. I've never really understood if it's bad or good. I don't know, but it is. It is. And you can even add functions. So we can use this function pointer things from before, and now we can actually add functions to objects that are dynamically created. So you can dynamically create objects with fields and functions and everything. I'm not sure how popular this is. Like, how many of you have actually written this in production code? 1, 2, yes! This is probably like one of my most like happy surprises. I don't know why, but this is kind of like, I don't know, there's, you have this culture that is very serious, like, you know, like very much C++ influence and Java influence, and then suddenly you're getting more and more functional with all of the linky stuff, and then it's like, whew, we're just going to go all out JavaScript. I like it. Anyway. But if you're going to choose a language, and I've been thinking about this a lot in the last few years, especially because we're getting new languages like Go and Rust, and they have like really, really big fanboy communities. And then I have to think, like, what would make you choose a specific language over another language? What are C#'s killer features? And before I started learning C#, people kept telling me that C# is like Java. But C# isn't really like Java. And I mean that in a good way. But I need a list. And it can't be just like, why would I choose it over another one? Because it can't be just nice to have things. If you know a language, you will pick the language you know, most likely, because it's easier. But what surprised me was that the reasons I would choose C# was none of the things that I've shown you already. The primary reason would probably be platform integration. And I had to think about this for a long time, because this is something that's really bad in Java. Platform integration in Java is horrible. If you ever want to call like a platform library on Java, that is like the worst thing. Don't ever do that. And so I would say in this respect, C# now, being much more portable than it was, and even moving to being even more portable in the future, I think it's probably rivaling Go, which I didn't expect. Because one of the features of Go is good platform integration, while at the same time being a safer language. And so I would actually say that Go and C# are much more competitive in style, and probably also Python, than Java in that space. And the other thing was Link, of course. Because everybody told me, what is the best thing in C#? Everybody told me it was Link. And it took me a long while just to understand all of the syntax. I had to learn all of the delegate stuff, you know? It took a long time. But I got to Link, and I have to say, I like it. But I like it in the same way I like SQL. And that's a hard thing. And it's funny how you have both types of syntaxes. You have this extremely functional, monadic kind of interface, and then you have this very SQL-like interface. But I would say that if I had an application where I needed actually to do real SQL-like operations, I would prefer C#. And I would prefer C# over basically every other language. And it's funny that those are the two things, because for me, coming to C#, I thought C# was a Windows programming language. But I've been programming C# exclusively on Linux the entire time. Of course, I started off really badly because I Googled how do you run C# on Linux, and then the first hit was install mono. Whew. That was a rough first start. But thankfully, Twitter steered me in the right direction, and I've been very comfortable programming C# on Linux. And I think, especially now with cloud and everything, then having good platform integration from C# to Linux and having things being properly portable, I think would make C# a very good backend language for cloud. And better than Go, actually, because Go is still very young and it's still very small. It's not as expressive. And Go has some nice features with very high level, like concurrent paradigms. But there are also a lot of that in C# now with async and await, but it's not as expressive maybe as Go, but probably will be. So I was surprised. I like C# a lot better than I thought I would. But back to how do we learn? Because that became the thing that I thought about all through the process. How do we actually learn how to program a new programming language? And I came to the conclusion that this is the best way to learn a new programming language. Rewrite an application you've written already. Take something that you know how it works, you know all of the things it needs to do, that you've written it in something else, and then rewrite it in the new language. And the reason for that is you don't want to think about application logic. You just want to focus on the language. How do I do this thing that I'm used to doing in this way? How do I do that in the other way? And basically, in the beginning, you're basically Stack Overflowing all the things. But you have some kind of framework to put it in. You have some kind of mental model to put it in. So I think this is the best way. But it still leaves, what are the unknown unknowns? You don't know what you should Google. You don't know that, oh, in C#, the idiomatic way to do this is to use this thing. If you don't know the language, then you don't know what is idiomatic. And this bothered me. Because how do you get confident? How do you feel that you know a language when you're basically just mapping from your previous language? How do you know that you're proficient in this language? How do you know you're idiomatic? How do you know you don't have an accent? Because you have all of these overlapping things of inheritance and cherry picking of features, but what ended up bothering me were the unknown unknowns. What are the things that I'm missing? What are the things that I don't know I should know? So then I started to think back, because I have done this before. I didn't know, like I went to my interview at Opera, and they had sent me like this programming test, and I'd written my program and sent them to them, and then they were sitting there with my program on pages like you did. And then and one of the guys goes, oh yeah, but you know C++, and I'm like, no. And they were like, and everybody kind of stopped and looked at me, you don't know C++? And I'm like, no, the first program I ever wrote in C++ was the one I sent you. So how was it? So I started in my job, because and they asked me, so what do you know? And I was like, I know Java and I know some C. And they said, oh yeah, okay, you're good. It's like, okay, spoiler alert, I was not good. I was not good at all. But what I did was basically, they gave me a CVS password. They said, here's a browser, go make features. CVS was Git for old people. Anyway, what I realized is the way that I learned C++ is probably the best way to learn a programming language. It is to make something interesting, because if not, you're just going to throw it away and not bother to iterate over it. You're not going to live with your mistakes. You're not going to refine your code over time. So make something that's interesting. But the most important thing is you need to sit next to someone who's knowledgeable and kind. Because those are the people who are going to look at your code and go like, yeah, this is going to work. But it's not really idiomatic. This is not really how we do things in C#. We would do it in a different way. And that basically means, I think, that learning programming is a social activity. And as senior programmers, a big part of their role is teaching. And coming back, which I've talked about many times, this peer review process, I don't think it's very interesting to talk about what's good or bad, but using it as a way to teach that this is how we do things. So this code that we looked at before, it's very clear that you can have an accent in code. And I have a clear C++ accent in this code. And then we call that, oh, it's not idiomatic C#, and it's definitely not. But where do you start if you're going to learn a new programming language? Because that's where I started, right? I'm going to learn this new language. How do I start? And procrastinate was state number 1. It's very easy to stay in procrastinate. It's very hard to figure out where to start. And so I would say probably anything that brings you out of procrastinate is a good place to start. Whatever it takes to get you to actually start is good. Maybe even submitting a talk to a conference. Thank you very much.